Hello. Yeah, good to see you again. This is Teacher Ed. Okay, and this is metric number three. Today is Sunday. I'm making a record at 5 p.m. and I will be here until like 6 p.m. Okay, and I want you to watch it in advance. And when we go to the class, we can have some discussion. Okay, maybe we can talk jokes. Okay, you know, right? So life will not be that much serious. Okay. Uh-huh. So the topic here is 1.11. It's about the minor. It's about the minor. You know, right? As the name states, like minor. When we talk about the minor, right? Sometimes we means like the kids, something, or something that is like small. So, so minor of a metric means that we have to find the determinant. We have to find a determinant, and we use some symbol like that. Mij of a, right? A is matrix A. So we find the determinant of the smaller square matrix, like by cutting something out and then compute the determinant of what is left. I will show you. I will show you about that. Okay. You know, right? And next one is a cofactor. Cofactor is something very similar to minor, except that you have to add some sign, right? I would okay. Let's say like this: you have to swap some sign. Okay, you have to swap some sign. And I set the rules like this for cofactor, right? Let's say you already have a minor and you want to find a cofactor. If the row plus the column is even, even, right? Even? Not even any, right? Even. Then you don't have to do anything. If the row plus column is even, you don't have to do anything. But if row plus column is odd, you know, right? You have to swap it. You have to swap the positive to negative. If you have the negative, swap it back to positive. Okay, get it right? So let's see what we can do about it. Okay, I have this one on page number 9, right? We have G, right? Big metrics of G, big metrics G, like this one, right? This is 3 by 3 metric, right? And I want you to find the minors of all the elements of all the elements. So let's start with this one, right? M11G. So that is minor of matrix G at the location 1, 1. So what do? You have to cut out row 1 and column number 1. And what you have left is that 3215, and you find the determinant of that. You find the determinant of that. So if we do it quickly, right? We cross multiplying down, we get 3 times 5 is 15, right? And then cross up. 1 times 2 is 2. So determinant is cross down minus cross up. 15 minus 2, we get 13. Okay, so that is the minor 1, 1, right? We cut row 1, we cut column number 1, and we find the determinant of what you have left. Okay, easy, right? Very easy, right? I know you want this one in exam. I know. It's so easy. I don't give it to you. I'm a bad teacher. Okay, so that is 13, right? Next one, we move to M1, 2, right? M1, 2. 1 and 2. So let's cut 1 and let's cut 2. Row 1, column 2. What you have left is that 2, 5, and 4, 2. You cross out, right? 5 times 2 is 10. Cross out 4 times 2 is 8. 10 minus 8 is 2. That is your minor 1, 2. That's your minor 1, 2. Okay, that's your minor 1, 2. Uh, I forget. What is that? No, I make a mistake. Okay. Let's find 10. Okay, that's 2. That's 2. That's 2. Okay. Next one, 1, 3, right? 1, 3. Okay, let's cut it out. 1, row 1, column number 3. Let's do it quickly, right? 2 times 1 is 2. 4 times 3 is 12. 2 minus 12 is 10, negative 10. Negative 10, right? So that is negative 10. Okay, that's negative 10. Next one, we go like 2, 1, right? 2, 1, you have to cut out row 2 and column number 1. So what you have is that 4 times 5 is 20, and 1 times 3 is 3. 20 minus 3 is 17, right? 17, right? 17, 17. I don't do it wrong, right? Correct me, okay? Talk to me. Oh, no, you cannot talk. Sorry. Okay, next one, right? M22. M22. Okay, this one. Cross down. 5, cross up. 12. 5 minus 12. That's negative 7. That's negative 7. Yep. I write it down. Next 7. Next one, M23, right? M23. Column 2, no, row 2, column number 3. Cross down is 1, cross up is 16. 1 minus 16 is negative 15. Yeah, write it down. Like chill out, chill out. So easy. Next one, 3, 1. Row 3, bye bye. Column 1. See you later. And then do it. 4 times 2 is 8. 3 times 3 is 9. 8 minus 9 is minus 1. Shup, write it down. Minus 1. Right? This is M32. And 3 and 2. Cut out. Cross down 2. Cross up 6. 2 minus 6 is negative 4. Right? Last one now. Last one. Last one. 3, 3. Cut the last one. Cut the last one. 3 minus 8. That is minus 5. Shup. Yay! Finished. Minus 5. Okay, so now we already finished finished about the minors. You know how to find a minor of matrix at any location, right? At any location that you want. So let's go to the next thing, right? The next thing it is say the minor matrix of G. Minor matrix of G. So when you see this word like matrix, you already know what is the minor. Minor matrix means you have to put all of those 9 numbers into a matrix. So let's do it quickly. First one, 13, right? Next one, 2. Next one, negative 10. Write it down. Shup. Write it out quickly. Next one, 17. Next one, negative 7. Next one, negative 15. Next one, minus 1. Next one, minus 4. And the last one is minus 5. Yay, that did finish. So, minor finish. Minor matrix finish. Next one is cofactor matrix. Cofactor matrix. Okay. Easy. I tell you, it's so easy. So let's see. Do you still remember the rule? Right? If you cannot remember, we go back a little bit. I tell you that if you have the minor matrix, right, you have to swap the signs. If the row plus the column is even, do nothing. Be happy, right? Let's go to do something else. But if I plus j or row plus the column is odd number, you have to swap the sign from negative to positive and positive to negative. Okay, 1, 2, 3. You know it, right? Let's do it. Let's do it. Let's do it. So this one, right? Let's start. Chip. I know that I'm gonna have something very similar to this one, right? Very similar to this one. So I go. Okay, this is 13, right? 13 is at location 1, 1. Then I know I is 1, J is 1, I plus J is 2, and I know the 2 is even number. So what's the rule? When it's even number, do nothing. You can just copy and paste the 13 there. Okay? So next one, next one, next one. We are done with this one. I will move to next position. This number 2 is at location 1, 2, right? Row 1, column number 2. You add 1 and 2. You have number 3. Hey, 3 is art. 3 is art. Art, art. Swap it. Swap it. You swap it to negative 2. Easy, right? So easy. Next one. This is like 1, 3. 1 plus 3 is 4. Don't do anything, right? Yep. And I tell you the patterns. You know the patterns, right? Pattern is the pattern of it look like this. Yeah, the PERN, like the pattern of it looks like this. This one, you don't swap, right? You swap, and then you don't swap. So next one, you will swap it. Next one, you don't swap. Next one, you swap it again. So negative 15 will be positive 15, right? This one, you don't swap it. So it's minus 1, right? Minus 1, you don't swap it. Next one, minus 4, right? Here, you have to swap it to 4. And then last one, you don't have to swap anything. It's minus 5. Okay, so you get it, right? So when you want to change the minor matrix into the cofactor matrix, what you do is to swap the sign from positive to negative, negative to positive. Swap it opposite at this, 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 and this location because the 4 of them have I plus j equal to odd number. Then you have to swap them. For the other numbers, do nothing with them. Okay, right? You get it, right? You get it, right? Okay, I wish that you can talk to me. I wish you can talk to me. One day I'm gonna make it live for you. I'm gonna make it live. So, but I'm not good with it now. But soon, soon. That's a promise. Okay, your teacher will keep the promise. I'm gonna make it better. Okay, so next one, right? We will talk about a little bit of like the applications. Okay, application of minor and cofactor in the determinant. Okay, in the determinant, right? Okay, let's look at this one. Right? Look at this one. Okay, if you have a 3 by 3 matrix, right? Your matrix has like 3 rows and 3 columns, and you know it. You cannot just do like a cross down minus cross up, something like that. Okay, because you will miss those elements, right? You will miss those elements. But if you know minor, it's a if you want to find a determinant of any matrix, right? Any metric, it doesn't have to be 3 by 3. You can go to 2 by 2, 4 by 4, 5 by 5, whatever you want. It. Step number one, you choose the row or you choose the column that you like. Okay, choose it. If you choose row one, you don't like row one, you can choose like row two. You don't like it, you can choose row three. But if you hate the word row, you can go with the column. You can go like this: column one, column two, or column three. Choose the one that you like, but you cannot choose it like diagonally like this. You don't choose diagonal. Okay, so you have the option: choose the row, or maybe choose the column. Okay, and then you go for it. Okay, it's a determinant is cofactor 1 1. Okay, multiply with this G11 cofactor 1 1 multiply with G11, something like that. Cofactor 1 2 multiply G12. What is that? And cofactor 1 3 multiply G13. If you look at 1 1 1 2 and 1 3, I know you're smart. You're smart. Some of you are smarter than a teacher. Some of you can be my teacher. So that one is like I I choose this, right? I like row one. So I choose row one and then I just go. You what you have to do is you multiply the cofactor. Okay. You multiply the cofactor with the A. I'm sorry. I think I write it wrong at here a little bit, right? I need to write something like A11. I'm sorry, okay? I'm sorry. But anyway, I'm gonna fix it. Never be afraid of mistake, okay? Mistake is like the raw material for you. You keep the raw material, you collect it, and you cook it better. You make the food better. Don't be afraid of any mistake. Accept it and improve it. Okay. So I should write actually C11, cofactor 1 1, multiply the first that member A11, right? Determinant of A, matrix A. So A11 is there. A11 is there. And C12 is a cofactor 1 2, multiply with that member A12. Next one, C13, right? Multiply with that A13. You get it right? Smart boys, smart girls, okay? Yeah. So I will teach you a lot of things, okay? Maybe sometimes it's academic, sometimes it's not. But as a teacher, I will teach you everything. I give you all the knowledge that I have. I'm gonna be happy if you are very successful in your life one day. Okay. Okay. Sure. Blah blah blah. Those are the things like symbols, and it looked like what is that? What the heck is that, teacher? What the heck is that? I don't like it. So we will move to the number. We will move to the number. Okay. Let's do it with a number. Okay. To find the determinant, right? If you want to use the cofactor method, then you can choose any row or any column that you like. Okay. So you can choose maybe this first row. Maybe you can choose the second row. Maybe you can choose the third row, or maybe you can choose the first column, the second column, or the third column. So you can choose anything that you want. But I think that this time I'm gonna make it a little bit different. I think I'm gonna choose this one. I'm gonna choose 6 column of 3, 2, and 5. Okay, so let's do it. Okay, so we're gonna have to start like this. We will have to write the members. Okay, so we start writing number 3. Okay, number 3. Right, write number 3, and you look like number 3 is here. It's row 1, column number 3. Right? This is row 1, column number 3. So 1 plus 3 is even. We don't have to do anything. Like we don't have to swap this sign. Okay, and then next, you have to cut it like this and find the determinant of this, like these 4 numbers. So let's find it. Like Cross down is 2. Cross up is 12. Yeah, 2, 12. So you subtract them, right? Down minus up, we are going to get negative 10. Okay, so we will get negative 10 at here. Yeah, negative 10 here. Okay, next one. Next one, I'm done with number 3. Now I'm gonna move to number 2. This one in the middle is that number 2. So I come here to this number 2. I write it plus and then number 2, and then I look at this one, right? Because when we find a cofactor, we have to find a minor first, and then uh, switch the sign, or switch from positive to negative, something like that. But to switch or not to switch, you just have to check at the sum of the dimensions of it, right? Not sum of dimension, I'm sorry, it's sum of the address. Okay, sum of the address. Like this number 2 is at row 2, column number 3. So if you sum the two numbers at the address, like 2 plus 3 is 5, and 5 is odd number. 5 is odd number. So if it's odd number, you know that you have to swap it. If it is even number like this one, right? Like this number 3, you don't have to swap anything. So this one is 5. 5 is odd, so you know that you have to swap it. So let's do it. Okay, number 2, like you cut it out like this, and then you find the determinant of these 4 numbers. Okay, down, like cross down is 1, cross up is 16. So determinant is down minus up. We have 1 minus 16, that is negative 15. You need to have like negative 15 like this. You need to have negative 15 like this. But since we calculated here, right, we got 5. 5 is odd number. So this negative 15, we have to swap it to positive 15. Okay. So let's go back a bit. I'm going to write again. Change it to positive 15. Okay. So we're done at 2 numbers now. So we want to move to the third one. And the third one is number 5. Okay, the third one is number 5. So we write number 5 now, and then cut it out like this. Find the determinant. Down is 3, right? Down is 3. Cross up is 8. 3 minus 8 is minus 5. 3 minus 8 is minus 5. It's minus 5. And then we go back to this number 5, right? Number 5 is at row number 3 and column number 3. So 3 plus 3 is 6. 6 is even number. 6 is even number. So we don't have to swap this one. Okay, we don't have to swap this one. The negative 5 is to negative 5. Okay, so let's go. Let's go next. Right? 3 times negative 10 is negative 30. And then we add it with 2 times 15 is that is 30, and this one is minus 25. So luckily, right, we have the same numbers, but just the opposite. But they are opposite, so we can just cancel them like this. And at the end, we have the correct answer of negative 25. Okay, so I think that it's not so hard. If you want to try it by yourself, maybe you can choose like the other options, right? Because we have like 6 options. You may go row 1, row 2, row 3, column 1, column 2, or column 3. I did this one already, so you can try your own on the other options. Okay, so that's it. This one, you want to find a determinant, right? Det f or sorry, det f, or that looks like the absolute, but actually it's not absolute. This one is short for the determinant. Okay, but you know, sometimes people is lazy, right? Don't say that you're not lazy. When you are lazy, you trying to develop something that will make you rightless. Yeah, I know, right? So um let's choose the row, and let's choose the column, right? So let me take a look a little bit, right? I scan it, and I think that this one is good. This one is good. I'm gonna choose this. Why do I choose this one? Because I see that it has a 0 at here, and I see that the number is all like positive, you know, right? Positive number is easy for the calculation, and 0 is a number when you multiply with anything. This one is, I don't know, right? Maybe it's big. It's so hard to compute, but when it is multiplied with 0, it's 0. Your job is done very quickly. You know what I mean, right? This is so hard. You don't know how to do it. What the heck is this? Teacher, kill me. If you don't kill me, I jump out the building now, like that. But when you multiply with 0, the hard thing is going to be Yee, something very easy. You know what I mean? Like 0. So choose the row or choose the column that has a 0. Or you can choose this one too. I choose this one. Maybe you want to try to choose this one. Choose this column. Yeah, how about this one? Okay, okay. I know, I know. I did the row for you, right? I did the row. I chose the row for you already. So you know how to work with the row. So this problem, this F thing, right? I'm gonna choose that column, and we're gonna try to work with the column. Okay, okay. Let's make things different. Okay, so you see it in both ways. Okay, in both ways. So I can choose this one because I have a 0 at here. Even this is negative, but it's okay. Anyway, the size of number is very small anyway, right? Okay, let's start. Let's start, right? So I'm gonna have to find a location of this one is row 1 and then column 3. So I'm gonna find a C13 multiply with F13, something like this, and add with this one, right? This one is cofactor of row 2, column 3, right? I need to multiply with the member, the entry, member. Okay, a friend like a friend of you came to ask me last Friday, uh, asked me like entry and member, uh, entry, no, not member, entry, member, an element, teacher. Are they the same? I would say, yeah, they are. They are the same. They are the same. They are the same. Something like you want to talk about water, you want to talk about H2O, right? They are the same. They are the same thing. Or they are the same thing, right? Nothing is different, okay? But the different is only the writing, but the meaning is the same. The meaning is the same. So, okay, let's go back. Let's go back to our topic again. Let's go back to our topic. This one C23, right? I'm gonna multiply with this entry, I remember the same, right? Or the element, okay? I'm multiply which is -2, right? This -2 is at location 2, 3. And this is big F, so this one has to be small f, 2, 3. And then add it with the last one, right? This one is 0, C33, and F33. And then you can just cross it out like this. You don't have to do anything with this one because this C, sorry, not this, this guy is 0. This guy, when this guy is 0, everything is 0. Cross it out. Cross it out. You don't have to work with that, right? So let's see. You see. I think that you understand how to choose the row or to choose the column now, right? Choose the one that has a lot of 0. Choose the one that has a lot of 0. Okay, that's a technique. Okay, that's a tips. That's a tips. Okay. Toot, 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 toot. Okay. Then let's see. C13. Okay, let's find a cofactor, but before cofactor, we need to have the minor. Okay, find minor 1, 3, right? Cut this one, cut this one. Yeah, because 1, 3 is there. So what you have left is those number. Cross down is 4, cross up is -3. 4 minus -3. I'm getting right. 4 minus -3. That will be the sum, right? Minus of minus is a sum. 4 plus 4 sum with 3 is 7. So that is our minor. And look at this location, right? 1, 3. 1 plus 3 is 7. Is even. You don't swap that. So this one is going to be 7. This one is going to be 7. Okay, let me go back a bit. Okay. So okay, we are going to have like 7. We can have 7. Okay, this one is 7, and then the member is 1, right? F13 is 1. Okay, finish. Right. Next one, C23. Let's find M23. Ship, cut it out like this, and then what you have left is that 2 times 4 is 8, right? Cross down is 8. Cross up is 0. So 8 minus 0 is 8. And then this one, right, 2 plus 3 is R. So you have to swap your 8 to -8 for your cofactor. And F23 is going to be this guy, -2. -2. So compute them. 7 times 1 is 7. This one, -8 times -2, they have the same sign. So your result will be positive 16. Add them up, that is 23. Okay, that is your answer. Easy, right? That is so easy. That is so easy, right? That is so easy. So easy. Okay, so now when I'm done with this, right, I'm gonna work on the determinant a little bit. I think I'm gonna use the same problem, this one, right? This F thing, right? The same problem, but we are not going to use the cofactor method, right? But we will use like a shortcut. I know you like the shortcut, right? You like the shortcut. You like it. Yeah, I know you like it, so I give it to you. Right? If it looks like this, you want to find determinant of f, so you can just write 2, 1, minus 1, 0, 3, 4, right? Write f down, like write what f has down. Something like this. This is a shortcut. And then you have to add, not add, I would say like copy this one, the first column, the second column, you copy them and you write it here again. You write it here again. Uh-huh. And now do it like this. To find determinant, you have to cross down, right? You find the cross down minus the cross up. So let's find it. Okay, I'm gonna change to the other color so that it will be very different. Yeah, rate one, rate. Oh yeah, rate one, rate one, rate one. Let's go. Let's use the rate one. Okay, cross down like this. That is 0. Cross down again. That's a 0. Cross down. That will be 4. Right? You add them up. So what you have is the sum of 4. Okay, the sum of 4 now. Next one, you already finished your cross down. Let's go for the cross up. Yep. This one is going to be minus 3, right? Minus 3. This one is going to be 4 times 2 is 8. That is negative 8 because it's negative. Negative 8 times 2 is negative 16. Right? And this is 0. Add them all. You add them all, right? That is negative 19, right? Negative 19, right? So your cross down is 4. Your cross up is negative 19. Determinant is cross down minus with the cross up, right? The sum of cross down minus the sum of the cross up. So result is 23. Yeah. I think this is fast. No, this is faster than the original method, right? Yeah. You see it? So this method, or this method, have the same answer. Your choice now. I give you the guideline. I give you the gun. I give you the knife. Up to you. You want to use the gun or you want to use the knife? Up to you. All the same, right? Same answer. Correct. You know, right? You kill someone with a knife, he dies. You kill someone with a gun, he dies too. But up to you. Okay. At the end, it will be the same. Okay. So you see the tips now. You can use them. Okay. You can use them in the classroom. You can use them in the exam. Okay. So next one. The next topic is going to be about the what is that? Square matrix, right? Square matrix. No, 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 the square matrix. I need to talk about this guy, right? Singular matrix. Singular matrix. It's like a square matrix that have. Oh no, that doesn't have a matrix inwards. Yeah. So that is the meaning of this one, right? It is the square matrix that doesn't have a matrix inwards. So how do we know? I tell you with this example, right? If you are trying to find a determinant, cross down minus cross up, right? Cross down is 12, cross up is 12. 12 minus 12 is 0. Yeah, that's singular matrix. A singular matrix or a matrix that has no inverse, right? Single. You know single, right? No boyfriend, no girlfriend, no baby, nothing. So, yeah, if determinant is 0, you have a singular matrix. Okay, let's see. Let's see this one, right? Okay, determine that A is a singular matrix or not. You have to find that A, right? So up to you now. You can use the cofactor method, or you can use the if you want. If you don't want to use the, I'm gonna pause. Okay, I'm back again. Right, you know, something went wrong. I saw like some lacking on the screen. You know, right? I write and I write already, but on the screen just show the thing that I write like one or 2 seconds later. So I went to fix the problem. Okay. Okay. So we're gonna find this determinant of A, right? So let's use a shortcut. Like, I'm gonna write it down at here now. I'm gonna write it down, right? You have to copy the first column and the second column, right? So you write 1, 1, 2, 3, 4, 5 there. Okay, and then you go cross down. That is 16. Cross down. That is 12. Cross down. That is 10. Add up. Add up. That will be 28, 38. Okay, 38. I write it down. 38. Right. So the sum of all the cross down, right? Sum of all the crossing down is that 38, and cross up 16. Cross up is 10, and this one cross up is 12. Right. Add it up. Uh-oh, that is exactly 38. Yes. So it's 0. When it's 0, it's singular matrix. And that singular matrix doesn't have inverse. Okay. Singular matrix. I would just write it like no inverse. Yay. And what's the meaning of that no inverse, right? If you have a question now, you have to wait a bit because we will talk about the inverse later. Not now, not now, not now, but I will. Okay. So let's go next one. Uh-oh, property of the determinant. Property of the, why do I have to zoom it? Okay, property of determinant, right? So it goes like this. 1, 2, 3, and 4. I think that if I read it to you now, when I arrive at number 4, you will forget the number 1 already. So I'm not gonna read it for you. What I do is I will just go back. Oh no, not go back. I will just go to the next page. I'll go to the next page, right? And I will do the exercise. I'll do the exercise. Ah, okay, so I will just do the exercise and then I will show you how to use the property of determinant, right? Okay, so here you have that is your A, right? And that's your matrix B. I want you to find the determinant of A square B. So you have like two options. Option number 1, you find A square, right? This is A square B. It means that you have to find A square. When you have A square, you multiplied it with B, right? With B. So you have to do at least how many steps, right? So step number 1, you multiply A with A to get A square, right? Step number 2, you have to multiply that A square to B, yeah, to get your A square V. And step number 3, you find the determinant, right? And you know what? Matrix multiplication, something like this is not easy. It's not easy. So what is our option? We will use the property to make it easier. Okay, right? Make your life simple. Come on, right? And keep the time. Keep your time to do something that you want to do. Okay, make it simple. What is that? Not now. Okay, next one. Okay, so let's do it. Like, so you want to find determinant of A squared B, right? So what can you do? Let's go back to the previous page, right? Previous page. So it says like if you look at number 2, right? If you have determinant of matrix A times matrix B, you can just split them up into det A times det B. So I'm gonna use this one on this problem. On this problem, I have this A squared times B. I'm gonna split them out like this, and I write the det of A squared times det of B. Okay, and then I think I'm done with this. Det B is easy. I can just go to find det B from here now. But this one, det A square, right? I think that I still have to use one more properties. So I will just go back. I will go back. I will go back. I will go back. I see this one, right? At number 4, it say det of any matrix that has the power on top, right? Det of any matrix with power, what you can do is you find determinant of it and then power it later, right? Okay, so in that case, we have this one like det a square. So you don't want to do a squared by like 8 times a. That is hard. That is complex, right? So what you want to do is you want to find, you want to change it to that a, which is just like cross down minus cross up, and then you square them. Okay, you get the idea, right? So let's use property number 4 in this one, like in our next step, right? So this one, that of a square, we have to change it to that of a, and then all of them square. Okay, step by step. Okay, step by step. I think that you will not get confused because I go slow and I go very very clear step by step. Okay, and let's see what is this one. I did a square, right? Cross down, that is 1. Cross up, that is 3. 1 minus 3 is negative 2. So you have negative 2 for that a, but you have to square them up. Sure. So write it, write it. That b, like cross down is 0, cross up is negative 6. So you go 0 minus minus negative 6. That is 6, right? As a result, it's 6. So you go. Negative 2 square is 4. 4 times 6 is 24. So you're done now. You're done now, right? So that is how to use the properties of determinants. So you can see that we already have our answers, but we never have to do any matrix multiplication, which is hard. Okay, so that is the what should I say, like the benefit of knowing. I would say like you know what, you spend more time a little bit to study some properties and then spend a lot no, not spend, like save a lot of time on doing those boring things. Okay, yeah, that is life. Sometimes you have to work hard on something to save your time on something. Yeah, you know what I mean, right? Okay, next one. Next one, right? This example, we will use properties again and say if the determinant of a square matrix that has a dimension of a 3 times 3, like 3 by 3 is 2, right? It's 2. It's 2. And then you have to find a determinant. Oh, damn. Oh, damn, right? It's not easy. So let's use these properties. You see that you have this matrix like 2a transpose, a negative 2a transpose times with that a power 4, right? So you split it out like this. You remember this? You still remember this property, right? So you write it down like determinant of negative 2, negative 2a transpose. And then the other one is determinant of, the one is determinant of a to the power 4 like this. Okay, and then go back to the properties. But before that, okay, maybe we can get this one done quickly, right? We can get this one done because we know it from that example, right? Det a power 4 is actually det of a like this, and then power 4 later. Find the det first and power 4 later. But if you do it directly, you have to go. Damn, right? I would say like step 1, you have to find 8 times 8 to get your 8 square, right? And in step 2, you have to multiply your 8 square and another 8 square to get 8 to the power of 4, right? Maybe that is like 5 minutes. This is another 5 minutes. And then somehow you make a little bit of mistake. Then your 10 minute is, damn, bye bye. You know, right? You waste your time, but so don't do it. Never do it. I would say, you know, I will just destroy it. Yeah, something like this to tell you that, like, yeah, don't do it, don't do it. This is very bad. Destroying it, destroying it. Okay, you destroy this idea out of your mind. Okay, destroying it. When you see this debt of a to the power 4, always use the properties. Never use that stupid idea. Okay, save your time. Okay, so now come back to this one, like negative 2a transpose. Let's go back to the properties a little bit. Woo, go back. Um, yeah, this one. Yeah, this one. K. K is. Uh, oh, I'm sorry. This one should be K. I find a mistake again. I get another material to make it better. I find a mistake again. Okay, so that is K. So that K is any integer. Okay, any integer. So when you have an integer multiplied or the scalar, yeah, I would say like integer or the scalar, they are the same, right? They are something different in writing, but similar in meaning, right? Similar in meaning. So when you have k like that multiplied in front of a, you can take it out. You can take k out, but you have to power up your k with n. With n. Ah, damn. I'm sorry. Oh, what did I do? I'm gonna have to fix myself. Fix myself. I'm sorry. I think my n is already correct. N is an integer equals to the number of rows. So number of rows. This is correct already, but I forget to write what is k. I need to write here. Okay, I shouldn't destroy this one. I should write most of something like k is a scalar quantity. Okay, k is a scalar quantity. Okay, k is scalar quantity. So when you see a scalar quantity in front of a matrix like this, you can take it out and then power out with that number of rows, power with the dimension of it. Yeah, dimension of your square matrix. Okay, dimension of your square matrix. Like, so you can have that k power n and then multiply with that a. Multiply with that a. Okay, so I think that's okay now, right? Okay, so we go back. We go back to our problem. We go back to our problem. Okay, so this one, right? When you see this, ah, -2. Yeah, you okay? So I'm gonna take you out. So take it out. Okay, this K, take it out. -2, right? You have to power out with the dimension. Ah, yeah, dimension is 3. So let's power it up. So it's gonna be -2 power 3, right? And then that's your matrix. So multiply with your det of A transpose. Okay? And now you don't know how to deal with A transpose. So let's go back. Let's go back. We have information there. We have information there, right? So this one, it's A. Det A transpose is equal to det A. Yay. So they are equal. So we go back. We go back. This is equal to that. So we can just combine them, right, into -2 power 3, that is -8, right? We finished this one already, the constant, we finished this one, right? And this and that, we just combine it to det A power 5. What? And what is det A? What's your det A? 2. What's your det A? That is 2, right? So just insert it there. So what you have, or you're just trying to one, right? It's going to be -8 times 2 power 5. 2 power 5 is 32. 32 times -8 will be negative, and then 8 times 2, it's 16. 8 times 3, 24, right? That's you see, yeah, 24 plus 1 is 25. Yeah, finish now. Finish now. Okay? Use the properties. If you do it directly, that is, like, that is killing yourself. Don't do it. Never do it directly. Okay. I will just try this one more. Chew, 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 chew. This one more, right? Don't never have the idea of doing it directly. Okay. If you see this kind of problem in the exam, right, and you don't know the property, just skip it. Just skip it. Don't try to do it directly. Okay. You're gonna dine. You're gonna dine. Okay. Never do it directly. And then next one. That's the inverse, right? We talk about a singular matrix, right? We talk. I told you that if a metric has the determinant of 0, it's gonna be singular matrix, right? And singular matrix doesn't have the inverse, right? And I told you that. I told you that. We will talk about the inverse later. And now it comes. It comes already. Inverse of a matrix, right? Okay. So what is the method, right? What's the method, and why do we have to do it, right? I just talked to you something about, okay, let's see a little bit, let's see, da 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 da, invertible, no divisions, blah 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 blah. Okay, maybe you just go with the example. Okay, something like this. If you have 1 times 1 matrix A, right, and then it looks like that, your A inverse, like the inverse of matrix A is just that 1 over A. Damn, so easy, right? Dude, so easy. So, and then this one is so easy, right? This one is so easy. But I think I forget something or not. Ah, yeah, I forget this. Damn. Seems like today I have a lot of materials to go back to fix myself. Okay. This is a matrix, right? A inverse is a matrix. Where the heck is my box, right? Where is my box? I forget it. I forget it. I forget it. This one says we should have a box, right? We should have a box of it. So in words works like that. You just flip it down, right? For one by one matrix, right? A will be like 1 over A. If you want to get a matrix like on this one, like A is 3. A is a matrix. A has 3, right? You want to find A inverse. That is 1 over 3. Very easy. This one is same thing, same idea, right? And if you go back there, it says any matrix multiply with the inverse of it or any inverse of it multiply with the matrix itself, you will get that identity matrix. You still remember identity matrix, right? Identity matrix look like that, something like that. And you know what? If it's 2 by 2, it looks like that. If it's 3 by 3, it looks like 1 1 1 like that. Blah blah blah. You know, my writing is so suck. Okay, it's so suck. Okay, just don't care about this one. Okay, but I want to tell you that this is the identity matrix. Okay, so if you multiply your matrix with the inverse, like this one, right? A is A and N inverse 1 over A. If you multiply them, you're gonna see that you have a cancellation, right? So what you have is just this one, like matrix 1. Same like this one, like 3 and 1 over 3. If you multiply, you get matrix 1. Right? Identity matrix. This one and this one, you will get this one too. So you see it, right? You see it, right? So that's it. That's the idea of the inverse, right? Okay. So let's go next one. Right? Let's go next one. Okay, 2 by 2 matrix. 2 by 2 matrix now. So if you want to find 2 by 2 square matrix, like you want to find the inverse of it, the 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 formula is like this. A inverse is 1 over determinant of A. 1 over determinant of A. And then multiply with that. Oh, what is that? I tell you like this. Do you remember the diagonal, right? This is called the diagonal. So what you do, you have to, this is the the diagonal is like AD, right? AD. You have to swap it to be DA. You see, right? From AD, it will become DA. AD will become DA, and then the C, B, and C, you don't swap them. I mean, you don't swap the position, but you swap the signs, positive to negative, negative to positive. Okay, that's why we have this negative, negative. You get it, right? I tell you again, okay? I tell you again. Swap the diagonal, swap the position in the diagonal, and then swap the sign for the other two. Okay, and then multiply with 1 over determinant. Okay. Hey, I think I'm gonna let you think, right? I told you that, okay? It's singular matrix. Singular matrix. It has determinant equal to 0. And when determinant is 0, I tell you that it doesn't have the inverse. Why? Because of this one, right? When determinant is 0, you have 1 divided by 0. That is undefined, right? When you have undefined, you cannot do anything. In math, right? You have undefined, 1 over 0 is undefined. You cannot do anything. That's why we will never have the inverse. Okay, this one, right? I want to teach you how to find the inverse, right? I want to teach you how to find the inverse. So the inverse, if you want to find the inverse, this is what you have to do. A inverse is 1 over the determinant of A, and this one is something that we call the adjoint matrix of A. Okay, adjoint matrix of A. Actually, you have to work with a cofactor, right? With the cofactor, and then when you have the matrix of cofactor, you just have to transpose it. But that would take a lot of time. The shortcut would be like this. If your matrix A has four members like this, like A, B, C, and D, what you do, the shortcut is you have to swap A and D, okay? Swap the position of A and D like this. See? A will just go down and D will just go up, right? And next one, for this one, the upper triangular, and then this one at the lower triangular. You just have to swap the sign of it. Like at first they are like positive, right? At first they are positive, but you swap it to negative and a negative. But you don't change the positions. You don't change the positions, okay? Okay, so let's come here. This example, right, where I made a mistake. So let's swap it, right? This one, it okay. Not this page is not big enough, right? I want to get C inverse, then I have to find 1 over det C, right? 1 over det C. Det C is 1 cross down is 4, right? Cross up is 6. So det C is 4 minus 6. That's negative 2. And for the adjoint matrix of C, right? Adjoint matrix of C, I have to swap 1 and 4, right? So 1 will just go down, 4 will go up, right? For 2 and 3, I will have to give it a new sign. That's it. Okay, so let's multiply it into it there. Let's multiply it into it. 1 over negative 2 multiplying 4, we need to get negative 2, right? And then this one, right, is constant, multiplying to negative 2, it's going to come out to be 1. And this one, we need to get 3 over 2, right? And the last one is negative 1 over 2. Okay, so this is it, right? This is the inverse of C. Finding an inverse of any matrix of bigger dimensions, is that? Damn, what is that, right? Okay, so if you want to find the inverse of any singular matrix, singular matrix. Yeah, I forget a word again. Damn, damn, damn. I get a lot of mistake, right? I get many raw materials. Damn, I make a lot of mistakes, right? It should be like any non-singular matrix, right? Because a singular matrix doesn't have the inverse. So you can find the inverse of any non-singular matrix. Okay, non-singular matrix. So that is the formula. You A inverse is 1 over det A, right? This is the same. You have 1 over det A. And what is that one, right? This is like cofactor of matrix A. You remember cofactor matrix, right? Something about minor, right? When you have the minor, you swap the sign of the minor, positive to negative, negative to positive somehow to get a cofactor. And then you transpose. Transpose is to change the row to the columns and change the column to the row. If you forget it, it's okay because I'm gonna help you. I'm gonna do it with you one more time, right? So this one, we call this cofactor matrix of A transpose as the adjoint matrix of A. Yeah, so I would call it again. I read this one again. I would say A inverse is 1 over det A times the adjoint A. Okay, 1 over det A adjoint A, 1 over det A adjoint A, 1 over det A adjoint A. Okay, so you get it now, right? You get it now. Yeah. Okay, let's do the example. Okay, maybe I'm gonna do this one, right? And I think that I can just stop it here. Okay, I'm gonna do this one. I'm gonna do this one, right? Maybe this is like the last one because we have done it for nearly an hour now. An hour now, right? And on my schedule, this is like 6 o'clock in the evening now. I have to do this video for M4 your class, right? And next, I will do the statistic, right? I will teach statistics from Matium 2. I do the video, I make the video. And after the statistics of Matium 2, I will do a linear equation of one variable for Matium 1. Okay, so today, my schedule, I have to do like 3 videos. And this is the first one. Damn, this is a long day for me. Yeah, never give up. Just do it, right? Oh, let's find cofactor of matrix A. Cofactor of matrix A. And then we will transpose them. Okay, so before you can have a cofactor, you need to have a minor, right? So you want to go like this. Oh, okay. We write it down like this. We're gonna make it quick, right? So this one, if you still remember it, I tell you, right? If you get, I would say, okay, let's do it step by step. Let's do it step by step, okay? Take it easy. Make it like from 1 to 10, okay? Step by step. So step number 1, find the minor of this location. Shoop, shoop, right? So you go down, up. That is 15. That is 2. 15 minus 2 is 13. So you write 13 there, right? 13 there. And then you look, this position is like 1, 1, right? No. Sorry, not that. This position is 1, 1. 1 plus 1 is even. When 1 plus 1 is even, this is your minor. You don't change anything. Your minor is going to be equal to your cofactor. Okay, right? And then let's go next. This number 4, right? Shoop, shoop. 5 to 10. 4 to 8. 10 minus 8 is 2. But let me delete it out. This is 2, right? And location is row 1, column 2. 1 plus 2 is odd. This is your minor. You want to change it to cofactor. You need to add a negative. You get it right? You get it right? So we do it step by step. I'm teaching you how to change your matrix into the cofactor matrix. Okay. Okay. We make it quicker, right? And if you know, you can make it quicker. Okay. This one, right? Shoop. Next one, right? Cut it out. This location, cut it out. You go. That is 2. That is 12. 2 minus 12 is negative 10. Negative 10. So you're at negative 10. This location is 1, 3 like that. 1, 3 is the sum is even. You don't do anything. Yeah, next one, right? This 2, right? Shoop, shoop, right? 4, 5 is 20. 1, 3 is 3. So 20 minus 3 is 17. 17. You write it down. 17, right? This location is 2, 2, 1. Row 2, column number 1. So you have to swap it to negative. Oh, I would say like this. Okay, if you look at a pattern, right? No swap, swap, no swap. So this one will be swap, and this one will be no swap. This one you're gonna have to swap. You know what? Next one, no swap. This one you swap, and this one no swap. That's it. If you want to change minor to cofactor, that is the pattern. So let's see. This is what swap, no swap, no, no swap, swap, no swap, and it's swap, right? So this next one it's gonna be like no swap, right? This one is no swap. So this number, chip, down 5, up 12. 5 minus 12 is negative 7, and this is no swap. So you don't have to do anything with that. Oh, let me delete it out. Negative 7. Okay, next number is that chip, right? This is row 2, column 3, right? This one row 2, column number 3, right? Down is 1, up is 16. So 1 minus 16 is minus 15. And then sum of here is odd, so you have to swap. So down 1, up 16, right? Minus 15. Minus 15, you swap it to 15. You have to swap it to 15. Okay. Next one, right? Here, number 4. Foop, foop. Okay. This is location 3, 1, like that. 3, 1. So down is 8, up is 9. 8 minus 9 is minus 1. But here, 3 plus 1 is even, so you don't change it. So minus 1. Right, next one is here. Next one is here. Ship, 2. Down is 2. Up is 6, right? 2 minus 6 is minus 4. Minus 4, right? You should get minus 4 at here, right? But somehow, if you look at here, it's just like 3, 2, right? Location 3, 2. So 3, 2, sum is odd. You have to swap it to 4. You know you have to swap it to 4. So swap it to 4, right? Swap it back to 4. Right? And then the last one now. Yeah, last one. Last one. Yeah, last one. Okay. Ship, ship. You know, metrics. Uh, very simple, but a lot of numbers. And if you make one single mistake, it's over. You all gone. You know, you all gone. You did. Okay, one mistake, you did. Okay. So here, down is 3, up is 8. So 3 minus 8 is minus 5, right? This location is 3, 3. Yeah, this location is 3, 3. So 3, 3 is, some of them is 6, right? 6 is even number. You don't swap that. Uh, Finish now. So finally, so now I have a matrix of cofactor. This one, I have to swap it. I know I don't have to swap. Yeah, swap, but it's operation of transpose. I have to transpose it. Transpose is to swap the row to the column. So I go like this: 13 negative 2 negative 10. Right? I go 13 negative 2 negative 10 like this. That is how I do the transpose. This one, right? Negative 17, and then negative 7, then 15. This one, right? I change it to negative 1, 4, and negative 5. Shoop. Okay, that's it. I have my cofactor. I have my cofactor transpose now. Damn, this is called the adjoint matrix now. Adjoint matrix, not adjective, okay? If you say adjective, I kick your ass, okay? This is adjoint of matrix G. Yay! So let's go. Let's find a determinant. So I want you to do with cofactor method, right? Cofactor. Let's go. What is it like? Yeah, yeah, here, right? Here. We are done with this one now, right? We're done with this one now. We still have to find a determinant of G. Let's find it. Okay, let's find it. Use this. I'm so tired. I think I'm gonna use a shortcut. I'm sorry. Let's find it. Let's use a shortcut. You know the shortcut, right? Shortcut is to add 2 more columns at the back, and then down, 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 up, up, up. You know, and then subtract them. Okay. Let's see. I'm gonna write it at here. Okay. Oh damn, I shouldn't do that. Maybe here. Okay. I'm gonna write it here. I'm gonna write it here. Okay. So 1, 2, 4. Right. That is metric G. And then 4, 3, 1. And then 3, 2, 5. And then that is my matrix. Copy paste column 1. Copy paste column 2. Cross down is 15. Cross down is 32. Cross down is 6. Ship. Add them up. What? This is like 47. 47 plus 6 is 50. Right? Like 47, 47, 6 is 53. Okay. Up is 36. Up there is 2. Up there is 40. And then add them up, right? Add them all up, that is 38. 38 plus 40, that is 78. And then minus them, right? Minus them. You are going to get, let's get, yeah, write it here, okay? Determinant of G. Write it, yeah, maybe write it here, you get this 53 minus 78. That's going to be negative of 5 and 2. Negative 25. Yeah, okay. Now, let's find G inverse, right? G inverse is 1 over the determinant, 1 over negative 25. And then multiply with the matrix of cofactor of G transpose. So let's go 13, negative 2, negative 10, negative 17, negative 7, 15, negative 1, 4, and negative 5. Yes! I'm done now! Yes! You see, right? It's not easy. It's not easy. So, but the thing that you have to be very careful is do not make a single mistake. You make one mistake, it's all gone. It's all gone. Okay. I'm not sure. Maybe I have a mistake. Okay. If I have a mistake at here, you let me know. Okay. If yeah, because you see, it's not easy. It's not easy. Okay. So I'm done with the inwards now. Next will be like the inwards property, but I am tired now. I'm gonna stop. Okay, I'm gonna stop it here now. So next will be like matrix 4, right? I'm gonna start my matrix 4 at the inverse property of multiplications. But today I'm gonna stop here. So everyone, I wish that you will watch this video from home, and when we go to the class, we can have like discussions. Okay, we can have discussions, and I wish that the system is going to change. I wouldn't say like change. I would say this system that I'm doing with you will be like a revolution. You know, revolution. We change from something like dinosaur, you know, right? Something dinosaur. We're gonna change it to something very modern, something internet and technology. Yeah, go with me, okay? Go with me. If you wanna go with me, join me, okay? So feel free to make any comment. Yeah, feel free to make any comment below the video. I will just come to look at that. So see you on Tuesday. Yeah, Tuesday. See you on Tuesday. Okay, bye bye. Bye bye, everyone. See you on Tuesday.